Inequalities is also chapter 61 to 63 in your textbook in case you want to know what inequality is. It's important to go back and figure out in the last topic what an equation was. So if you save $15 each week and already have $120, to figure out how much money you would have at any given time, you need to know how many weeks you have. And you'd add the 120 you'd already had. And this would be an expression of time. Well, if you want to know when you'll have exactly $300, we can take our expression that gets us how much money we make and set it equal to 300 and find out there's only one amount of weeks that I can get to equal 300 plus that 120. So we're going to subtract 120 from both sides. We get 180. So you get 15W equals 180, and 15 goes into 180 12 times. So that would mean that after exactly 12 weeks would be the only time you'd have exactly $300. So we solved this equation and we got an exact answer. You wouldn't have $300 after 13 weeks. You wouldn't have $300 after 11 weeks. You would need exactly 12 weeks. So I can graph that on a number line if I wanted to. Here's the 12 because there's only one answer. So I'm going to put a darkened in circle right on the 12, because that signifies that this is the only answer that would work for us to make $300. Well, inequality is very similar to an equation, except instead of wanting exactly $300, you might want more than 300. So I'm going to take that same equation, 15W plus 120, and instead of wanting exactly $300, you want at least 300. Well, at least would mean that this is the amount of money you had should be greater than or equal to $300, because even though you see the word least in there, it means you could have $300 or more. Well, we're going to solve this. If I want to know how many weeks this will take, we solve it exactly like we solved the equation. We subtract 120 on both sides. We get 180. We bring down our sign, but it's not an equal sign. It's an inequality sign. We divide by 15, and we get that same exact answer, which I believe was 12. Yep. But instead of knowing that the weeks have to equal 12, we get that the amount of weeks could be greater than or equal to 12. And that makes sense, because at 12 weeks, you're going to make $300. Well, if you add another week, like say you worked 13 weeks, you're going to have more than $300. So this would make sense. If you want to have more than $300, you could have a 12. So W is greater than 12. We want to represent, this is the answer, but we want to represent it graphically. We're going to graph it so we can see it visually. So you have a 0, you have a 12. I'm going to fill in the circle because you could work 12 weeks. You'll have at least $300 if you work 12 weeks. You'll actually have exactly $300. But also 13 weeks works. 14 weeks works. So I shade in to the right of the 12. I can even shade in the arrow because it goes on forever. And this shows me all the possible answers that W, which is the number of weeks, could be. So this could be W. This could be W. And actually, I could work 1,000 weeks if I keep going, and I will make at least $300. So these are all the possible solutions. And because you can't write them all out, we use a graph to represent them. Well, a couple things about graphing. You need to know how to always, when you get your answer, how to show what the answer is graphically. So x is greater than or equal to 5. We talked about that. You could put a 5. You do a closed circle, and anything greater than 5 could be x. So we show all the answers that x could be. Here, x is greater than 5. It looks almost the same, except instead of a closed circle, I'm going to put an open circle. I still want to shade to the right of it because 5.1 works, 5.2. But the open circle signifies that the answer can't actually still be 5. And I know that because it's not and equal to. Over here, x is less than 5. I'll put a number line. Some teachers make you put a 0. It really depends. Sometimes teachers just let you put the 5. But here, if x is less than 5, it can't be 5. But it could be anything to the left of 5, infinitely in that direction. X is less than or equal to 5. Well, it's going to look exactly the same as this, but instead of an open circle, we're going to put a closed circle to show that not only can x be less than 5, it could also be equal to 5. Over here is sometimes when you're solving an inequality, the x is on the right and the number is on the left. And So this, if you read it, you could kind of make sense for this. You could say if 7 is greater than or equal to x, well, so 7 is a number that's greater than x. That would mean that x is actually less than 7. So even though you see the greater than sign, you're graphing what x could be. And x actually has to be less than or equal to, so it's closing this, fill in the circle, 7. So when you read it, you could kind of think about what x could be, even though the 7's first. The trick is that if you ever get an answer with the x's on the right side, you can bring the variable over to the left. You could bring the, switch the number in the variable, and you could actually flip-flop the sign. And it works out to x is a number that is less than or equal to 7. And I showed what x could be by my number line. The other rule that you have to know, it's just like solving an equation except for one rule. The rule is whenever you, not when the answer is negative, but when you actually multiply or divide by negative on both sides, the sign will always switch. And the reason for that is if you think about this, negative x is greater than 10. Well, let's think of a number where negative x is greater than 10. Well, we can't put a 7 in there because negative 7 isn't greater than 10. So we'd have to put a number like a negative number, like negative 11. Well, if you thought of this, if x equaled negative 11, this would mean that negative 11 is greater than 10. Well, that's true. That's a true statement. So we have to think about what x could be. And in this case, x isn't going to be a number greater than 10, because if it's a number greater than 10, like 12, negative 12 is not greater than 10. And you have to use the negative sign, whatever you put in for x. So the way that we work around that is whenever you solve this for x, and we're going to divide by negative 1, the sign that you're using flips to the opposite. So it's not greater than, it's actually less than negative 10, which would make sense because now it's saying that in order for this equation, the original equation, remember, was negative x has to be greater than 10. So when I get an answer of x is less than negative 10, that would make sense because I could put in any number, that's the x right here, I'm going to put parentheses. I could put in any number less than negative 10, and this inequality will be true. So like, for instance, negative 14. And if you put in a negative 14, minus a negative 14 becomes plus 14, and it works out to be a true statement because surely negative 14 is greater than 10. So reminder is whenever you are multiplying or dividing by a negative number, you always flip the sign. So here are some examples that I'm going to do with you to show you. So each of these are going to be solve and graph. So we're going to solve them just like an equation. It's okay that I subtracted. I'm not going to flip the signs, only when you multiply or divide. So here we are dividing by negative 5 on both sides. So I have to flip the sign from a greater than to a less than. 15 divided by negative 5 is negative 3. So the answer is x is a number that's less than negative 3, and I'll show that on my number line by drawing in a negative 3. I'm going to put a 0. You don't necessarily have to do that. The answer can't, x cannot be negative 3 because it has to be less than negative 3, so I will only shade in to the left, including the arrow of the negative sign. Here's another one. Now there's variables on both sides. We do exactly what we did with equations. We want to move all our variables first over to the same side. So I'm going to add 4t on both sides to cancel it out there. 2t plus 4t. Bring down. Keep the sign the same because I didn't multiply or divide. Next, I'm going to subtract 13 on both sides so I can move the number over to the left side before I separate the 6. Negative 18 is, oh, sorry, I flipped the sign by mistake, is greater than 6t. And now I'm going to divide by 6. Now, notice that our answer is a negative 3, but I don't flip the sign because I divided by a positive on both sides. So my answer is negative 3 is a number that is greater than t. Or in other words, I can flip-flop them. T is actually less than negative 3. And on my graph, I have a 0. Here's my negative 3. The numbers that are less than negative 3 would be over here. Another problem, distributive property handles just like we do with equations. You first want to distribute 8m minus 2, bring down my sign, and we're going to do everything that we did before. Variables to the same side. bring down everything. And now in this case, I get m is less than or equal to negative 9. Negative 2 minus 7. And then the graph of that would be, here's negative 9, but it is less than or equal to, so it could be a negative 9. So I'm going to do a filled in circle or anything less than it. Couple more. Here I could get rid of instead of distributing the 3, I can divide both sides by 3. But if I do that, I'm going to have to divide a by 3 and negative 1 by 3. And I don't want to have to do that. It would cancel out here, but it would kind of make the right side a little more complicated. So instead I am going to distribute. 3 times a is 3a. 3 times 2/3 is 3 over 1. I could cross reduce, and then I get an answer of 2. So plus 2, which is greater than or equal to a minus 1. And notice I'm just going to solve it just like we would a normal equation. I'll move all my a's to the same side. And I get 3 is greater than or equal to, cancels out here. 1 minus 3a is a negative 2a. Now I'm going to divide, because I got to find out what a is, divide both sides by negative 2. And now notice I have to be very careful to leave the numbers on the side they're really on. Now I divided by negative, so it means my sign is going to go from greater than to a less than or equal to. And I have a. And remember we talked about it. You could always, it's better to write it the other way. Instead of 3 over negative 2, which by the way is the same thing as negative 1.5, a is, instead of that being less than a, that would mean a is greater than or equal to negative 3 over 2. Here's our answer. And on a graph, remember I know that if this is a 0, that's a 1. This would be like negative 1.5 or negative 3 over 2. The answer could be negative 3 over 2 or anything greater. So I'm going to go to the right. I think we got one more problem. So here is we have to talk about the kinds of problems even when you're working with inequalities. There are some times that the inequality will sometimes, always, and never be true. So all the ones that we just did, because we got an answer, they're going to be sometimes true. If you put a number greater than negative 3/2 into this original inequality, this side will be greater than that side. If you use something that's actually less than negative 3 over 2, this side will not be greater than that side. So that's why it's sometimes true. There are also ways that inequalities could actually be always true or never true. Here's an example of when I distribute the 5. I get an inequality where it's saying if I multiply a number times 5 and subtract 10, it will be greater than if I still multiply by 5 but add 100. And if you think about it, that doesn't really make sense. Why, if you're adding 100, how could that side be less? Well, just like before, what happens if I continue solving is our variables cancel out on both sides, and we're left with just 2 numbers. And when you're left with 2 numbers, you have to look at whether that statement is true or false. This says negative 10 is greater than or equal to 100. And that doesn't make any sense. Negative 10 is not greater than or equal to 100. So in this case, this is not true. So that means that this original inequality has no solution. There's nothing you could put in for a here and here which will ever make this side greater than this side. So in a way, this inequality is never going to be true. But the solution is there actually is no solution. When you're doing these problems and you get an answer that does make sense, for instance, if you get negative 5 is less than 7, well, that's a true statement. Well, that would be an inequality where x or a or whatever the variable is can be infinite solutions or all solutions. And that also then lets you know that the original problem would always, the inequality would always be true. Hope that helps, and good luck with your homework.